So we spent the last couple lessons defining piecewise functions and talking about absolute value functions. You should have done the do you know hows from 5.1 and 5.2. And today we're just taking a chance to do a little bit of extra practice in both those sections. So these are assigned in Google Classroom. You should be able to see them. They're attached PDF files. You cannot submit them through Kami. I don't have a license that allows me to see them. You'll have to save them and reattach them as files to submit. But let's just look over what it is. So 5.1 is based on the absolute value. So it just gives you a chance to look at a few different absolute value functions and sketch the graphs. So if we start with this first one, f of x equals 3 times the absolute value of x, I would notice that the domain is unchanged, the range is still all positive numbers, and it is just a vertical stretching of the absolute value function. So at -1 and 1, the value would be 3, and then it would just go. And I don't expect these to be perfect, just do as good as you can. If you get the 1 point on, it will be good. So go ahead and graph all of those. They give you big hints sometimes about what the shape would be based on what they've given you. And then there's a few questions. For these, you can always type in with the text. This one, number 8, a bus is traveling between 2 cities. This looks like the word problem that we did in class. I know it wasn't in the video that we gave for this lesson though. So let's look at the word problem here. A bus is traveling between 2 cities that are in neighboring states. The graph shows the distance of the bus from the state line, right? So I'm driving from New Jersey to Philadelphia. I have to cross the border between New Jersey and Philadelphia. What this graph is showing isn't necessarily the total distance that I've traveled. It's just telling me how far I am from the border to the next state. Okay? The graph shows the distance of the bus in miles from the state line. So where they start right here, it tells me when I start at time 0, how far am I from the state line? And then this is my distance as I'm approaching. Right here at this point, I am at the state line. Right? If my distance from the state line is 0, that means I'm at the state line. This is when I'm crossing the border into the next state. And then as I travel into the next state, that distance begins to increase again. So there is information that you can read from the graph about how far you've traveled in total, but it's not telling you, the graph itself isn't measuring how far. This distance is the distance from the state line. So if I start at 65 and the state states if I start 65 miles from the state line, you know that I've driven at least that 65 miles, but then I'm driving onto the other side also. So hopefully that will help you with those. The second question is about the average rate of change. So remember average rate of change, when we look at that, we are just talking about slope. The average rate of change is slope. But when we're talking about an application of a graph, it makes more sense to talk about the average rate of change, because it has meaning. The rate of change tells me how my variables are changing rather than just slope, which is an abstract idea. So that is the 5.1. So then if we look at the 5.2, I want to take each of these absolute value functions and write them as a piecewise defined function. So this is just like the example we did. I'm just going to take it and rewrite it in the form of a piecewise defined function. All of these at the end of the week, next week we'll talk about transforming absolute value functions. But all of these, I know my breakpoint is going to be at 0. So I know I just have to define it for x less than 0, x greater than or equal to 0. And if I'm multiplying by 7, it is just a vertical stretch. So for the negative numbers, it's -7 times the value, and for the positive, it is 7 times the value. So you just go ahead and do that for all of these functions. And then on these, which graph matches the piecewise defined function? There are no graphs. They've given you some plots that would make sense how to do these. Make sense of where to graph them. So you would just have to pick which place and then graph it. So this one you can draw here at x on the middle one. So my breakpoint is at 1. So if x is greater than or equal to 1, f of x equals -5. right? So I'm going to draw it here. So if x is greater than or equal to 1, it's -5, so I would just draw that line in. Continues going. For x less than 1, my intercept is -2, and I have a slope of -3. I'm just counting 1, 2, 3 over. This would be an open circle, but as it turns out, they match up there. So I can draw that in. So that would be an example of that line. You can go ahead and do the other two. Choose the appropriate spot and then graph it. So that's what I want you to do. Just get this extra practice. Make sure you've completed the Do You Know Hows if you haven't done them yet. And we'll come back and go on to the next section next week.